Welcome to the Minnesota Stormwater Seminar Series. I am John Gulliver, and I will introduce the seminar series and our speaker. This series of seminars is co-sponsored by the Water Resources Center and the San Antonio Falls Laboratory, both of us at the University of Minnesota. Our speaker today is Dr. Ryan Winston, who has a joint assistant professor appointment in two departments, the Department of Food, Agricultural, and Biological Engineering, and Civil, Environmental, and Geodetic Engineering at Ohio State University, the Ohio State University. And I've heard, so that means he has two bosses, and I've heard that he's doing a good job with both. He's also a core faculty member of the Ohio State University Sustainability Institute. So Ryan received a bachelor's degree from the University of Florida and MS and PhDs from North Carolina State University, where he was also a research engineer working with Bill Hunt, and has presented material in over 100 workshops, amounting to about 7 presentations and workshops per year. Ryan's research is focused on runoff hydrology and water quality and the performance of stormwater control measures. Ryan's background is primarily related to the management of urban stormwater using innovative green infrastructure techniques. He has led over 50 monitoring projects in 5 states to understand how stormwater control measures can provide ecosystem services. In many of these projects, field collected data were utilized to calibrate stormwater models such as US EPA SWIM, WindSlam, DrainMod, to understand how these systems function under a variety of design scenarios or under the impacts of climate change. In particular, Ryan has been involved in the design, construction, maintenance, and research on permeable pavements for about 15 years. He did his PhD thesis on permeable pavements. So he does know something about permeable pavements and the required maintenance, which he will be sharing with us. So it is my pleasure to welcome Dr. Ryan Winston.
Thank you very much, Dr. Gulliver. Very glad to be here today. I thought I would go neutral and go with my undergraduate colors here on my tie as opposed to Ohio State red. But of course, it does have to be on my slides. I guess that's a requirement of a paycheck from OSU. So very glad to be here electronically to speak with you all today about a topic that's near and dear to my heart. I've been working on permeable pavement maintenance since about 2012, so going on roughly a decade, and trying to understand really how to figure out how to design these systems, these permeable pavements better to reduce maintenance burden, understand how to plan for maintenance frequency, and really decide how the designs that we do as engineers affect that maintenance frequency. And then finally, testing out a bunch of different techniques, as you'll see, to understand how we can improve or increase the rate at which water flows through permeable pavements after it is clogged. So how can we rejuvenate the hydraulics, essentially? So that's what that really long title that you see there is trying to convey. So again, I'm really excited to be here. I'm hopeful that there's information here that will be valuable to you, whether you're a researcher, whether you're someone who works for a municipality, or even maybe someone who does this type of maintenance on a day-to-day basis. So to start the session, I really wanted to go back to the beginning, right? Through history, we as humans have built roads, right, for the last couple of millennia. And during that time, the design of roads has not really innovated much, right? We began building automobiles and cars about 120 years ago, but well before that, we were using horse and carriage and other methods to move goods and services and people, right? So one of the things that I really want to hit early on in this talk is the thought that we need to be innovating more in our imperviousness, right? A lot of the imperviousness in the Twin Cities and every city across the world is related to our roads, right? So if we can think about ways to at least change some fraction of those into perviousness, that can do a lot of benefit for things like stormwater control. And the picture on the right is an example of that, particularly for a highway. I promise you it is raining on both sides of this Jersey barrier. This is a porous friction course overlay, a porous asphalt overlay on a highway down in Texas, and then a standard asphalt highway on the right-hand side. So it gives you an idea of some of the other ancillary benefits of porous pavements related to splash and spray and hydroplaning reduction particularly. But in this case, what we're really going to talk about today are full depth permeable pavements, or pavements that are entirely permeable and allow water to infiltrate through the surface and typically then be conveyed to a sewer network through a drain of some sort, through an underdrain. Okay. So 5 different types I have shown up here, all of which have slight variations to the types of maintenance that may be required for them. Okay. So the 2 on the left are more uncommon. I'm really not going to talk to them much today. But for instance, turf reinforcing grids, you may actually have a grassed parking lot. You might have to mow it, right? So that's definitely dissimilar to a traditional asphalt or concrete surface, okay? But the thing that all of these have in common is that they contain pore spaces that allow the water to pass vertically through the pavement, as opposed to being transferred as surface runoff to our storm sewers through inlets and pipes, okay? So typical cross section for a permeable pavement is shown here. Essentially what it is a, let me get a laser pointer on here, is a porous surface of some sort. In this case, these are pavers with interstitial spaces in between that are porous. Porous asphalt, pervious concrete, both have pore spaces similar to this. And then underlying that are a series of aggregate layers. Typically, these are open graded aggregate layers, which allow for water storage. So there's tremendous porosity, typically somewhere in the neighborhood of 40% in these aggregate layers, which can be used sort of as subsurface aquifers. And as engineers, we can design for peak flow mitigation or for infiltration into the underlying soil and groundwater recharge. We can also get some minor evaporation that's occurring, right? And certainly through this cross section, we're also getting treatment of the water and improvement of water quality vis-a-vis typical urban street corridors that are impervious, okay? The treated water often is going to head out of the underdrain. Here in Ohio, we have primarily clay soils, and so we almost always have an underdrain with these systems. But really the fraction or the portion of the runoff water balance that we're trying to avoid is this surface runoff piece, okay? And the surface runoff starts to occur when the pore spaces in these systems get debris and material into the pore spaces that prevent the water from passing through them, okay? So that's what we're trying to avoid or trying to remediate when we maintain porous pavements, right? So right after construction, how should these things work? Well, we called up our local fire department at this particular permeable pavement site, and the guys and gals were super excited to use their hose, right, and spray lots of water on our permeable pavement. And so you can kind of pick a number here, but in terms of infiltration rates and how fast the water can move through the pavement, it's going to be many hundreds of inches per hour. Okay, so well above any typical rainfall intensity that we would expect to see anywhere in the world. Okay, so these things, when they're newly built, should be able to pass water just about as fast as you can measure, essentially. And then with time, as I'll show you in just a second, these infiltration rates slow. Okay, and as you maintain them, of course, you would expect the infiltration rates to increase following your maintenance efforts. Okay. So what's the reason why the infiltration rates decline with time? Really, it's, if you think about this stormwater control measure, the system is acting as a filter for sediment, right? We have dirty runoff coming off of a watershed that might be draining onto the permeable pavement. And even rainfall contains some sediment in it, right? So if it's just treating direct rainfall, you'll still get clogging over time as you get windborne dust and debris that's pushed onto the pavement, okay? So you can see here just some examples. This is from Elizabeth Fassman's work, who I know is a previous speaker on this series. And you can see here, this is traditional asphalt pavement, and then the effluent from a permeable pavement in Auckland, New Zealand that she monitored. And again, you can see here that the effluent from the permeable pavement is much cleaner. And the reason for that is that it's acting as a filter and it's trapping that sediment in the cross section, okay? And so that is naturally why we see a decline in infiltration rate as a function of time with all types of permeable pavements. Okay, so what I'm trying to say in summary is that with time and without maintenance, the pore spaces in these porous pavements, be it pervious concrete, porous asphalt, permeable interlocking concrete pavements, like you see here on the bottom, the bricks with the interstitial spaces in between, regardless of the type, they will clog up over time. And so we do need to have a proactive maintenance regime that is built such that we're able to ensure the hydraulic function of these systems over time. Because if we're relying on them for things like CSO control or SSO control, and they clog, you know, then there's going to be all that water again heading to the CSO, for example. So we really do need to ensure that the water passes through the pavement surface. Okay, so what I want to hammer on first is how design of these porous pavements affects performance. It affects how they function in terms of runoff reduction, particularly, and it also affects maintenance. Okay, so this is a picture of a typical porous pavement design here in Ohio. We have our permeable interlocking concrete pavement, which I will abbreviate PICP on the left here, and then a traditional asphalt portion of the parking lot. And it's canted from right to left in this picture. So we have runoff entering onto the PICP. We're allowed to have 2 parts impermeable to 1 part permeable here in Ohio. And that's what's called our run-on ratio. Okay, so 2-to-1 run-on ratio, again, means 2 parts impermeable to 1 part permeable. Other places in the country go even higher. Wisconsin can go up to 3-to-1 or even 5-to-1 in certain cases. And obviously, as you push more and more water onto the pavement, if that runoff contains sediment, which we all know it does, that is going to affect the rate at which these pavements clog. Okay, so this run-on ratio is in fact of major importance to maintenance frequency, and I'm going to touch on how that affects things in just a few slides. So I want to give you a taste of some of the porous pavements of many over the last 10 years that we've conducted infiltration rate testing on. There's 4 shown here. These 4 are some of the ones that we've collected the most data on. They're all in Northeast Ohio, and they have a variety of different designs, as I'll show you in just a second, particularly as it relates to run-on ratio. We've also looked at a variety of different pavement types, from PICP to porous asphalt to pervious concrete. Those 3 particularly have been the pavements that we've focused most of our research on. These 4 sites, we instrumented and did intensive monitoring of these sites. Actually, back during my PhD work, we collected the water balance on these systems over 18 months of monitoring and about 75 to 80 storm events. So really had a good idea of where the water was going and how the systems were functioning. And so to jam my a good portion of my entire PhD into 2 slides, here we go. I'm going to summarize the water balance for these 4 sites. Perkins Township, 2 sites at Willoughby Hills, and then Orange Village here at the bottom. And what I really want to hone in on as the primary design factor of interest is this idea of run-on ratio. And what you can see is that Orange Village was only treating direct rainfall, so had a run-on ratio of 0. And what that directly resulted in was 99 out of 100 raindrops that fall from the sky being abstracted or reduced and kept out of the storm sewer network. Okay, so we had a lot of infiltration into the underlying soil and evaporation back up into the atmosphere. The other thing you'll note is as the run-on ratio increases to 2.2 to 3.8 and then to 7.2 at the highest run-on ratio, you can see there's concurrent decreases in the amount of runoff that we've reduced. Okay, so as that ratio goes higher and higher, typically the runoff reduction is going to go lower and lower, just because we're putting more water through the system and we're hydraulically taxing it more. Okay. The other thing that happens due to surface clogging is that we end up with more surface runoff as a function of the total overall water balance across all of the rainstorms that we monitored. Okay, so in this case, we had up to 1/4 of the runoff at one of our sites that left the pavement as surface runoff. And that's the part of the water balance, again, that we really want to try to avoid because it is not really being treated, right? It's acting as an impermeable pavement at that point, okay? So I can come back and touch on run-on ratios and designs of these systems a little bit more in the questions if there's interest. There are some other interesting findings here that I won't touch on just in terms of keeping on time. So I wanted to make the point about what happens if you practice gross neglect with these systems over a long period of time. These data were collected with folks over at Luleå University of Technology in northern Sweden. This is about where Sweden and Finland come together, way up near the Arctic Circle. And these were two porous asphalt pavements that we studied while I was there back a few years back, one in Gammelstad and one in Haparanda. And these were built back in the mid-90s, so they're quite old at this point. And you can see they had measured how fast the water moved through the pavement, what we call surface infiltration rate, at construction, roughly 500 to 1,000 inches per hour, as I mentioned. And then they measured it at several points throughout the lifespan of each of these pavements. And these 2 points were when I was there for the testing. There's not a lot of data here, but what you can see is when you fit a trend through this, it looks linear, but in fact, this is a log scale on the y-axis. So we have an exponential decay that's happening here in surface infiltration rate. If you really want the equation, get super nerdy, you can look here at this particular equation. I should mention that these pavements were never maintained throughout their roughly 20-year lifespan at the time I was there. And the winter maintenance at these sites is all through the application of small gravel, because it's so far north that salt ceases to function essentially for de-icing. So, so over time, if you don't maintain them, essentially what I'm trying to say with this slide is the infiltration rate will go nearly to zero. Okay, that's what we found. By the time we were there, we were well less than 1 inch per hour of surface infiltration rate. And measuring that is best done by a graduate student with lots of time on their hands is what I would recommend, not by someone with lots of other things to do. It's quite a boring thing to sit and watch, if you can imagine. One other case study I want to give you relating design to performance is this Meyer store that we worked on here in Columbus more recently. Traditional Meyer, very much like what you might have in the Twin Cities. We retrofitted in a bioretention cell in one part of the parking lot, the watershed shown in green, and the bioretention cells here in the dot. And then adjacent to that, a permeable pavement with a similar watershed draining to it in purple, okay? And the thing that was really interesting about this particular site is that we had an extremely high run-on ratio, 27 to 1, okay? I don't often do this, but I'm going to beg right now. I'm going to beg you to never, ever, ever, ever push the run-on ratio this high, because this just flat, it just failed, okay? And I wanted to show you there is a point at which you can push things to the point of failure, and we kind of did it in this particular study, okay? So we also collected data on maintenance at this site, in this case over the first 18 months after construction. And you can see our surface infiltration rate data. We collected these every 3 months with the exception of the winter period. And again, as we look at kind of the decline in infiltration rates here, this decline is again approximated by an exponential decay. And in this case, the exponent on the exponential decay is quite a bit higher. And that we think is related to this much, much higher run-on ratio here of 27 to 1. The porous asphalts in northern Sweden were just treating direct rainfall, and so they clogged much, much less quickly, okay? But this site really had clogged to the point of being fairly heavily clogged, less than 10 inches per hour within 18 months, okay? And we'd done no maintenance over this period, all right? So you might ask, how does this clogging affect the performance of the pavement, okay? And by the way, we've seen exponential decays here in our research in porous asphalt and in permeable interlocking concrete pavements. John Sansaloni down at University of Florida has seen it in pervious concrete as well. So we think this exponential decline is the way to model this if you're interested in modeling clogging of porous pavements. So at this particular site, we also were collecting runoff hydrology data and rainfall heatographs. So on the left-hand side here, we have bioretention. This is the results of the bioretention monitoring, permeable pavement in the middle, and then the sum of the two, which we called LID on the right-hand panel, okay? Runoff reduction is on the top row, and peak flow rate reduction is in the bottom row, okay? So what I wanna highlight here is we did monitoring of the existing parking lot prior to construction of the green infrastructure stormwater controls. So the relationships of the existing runoff hydrology of the parking lot, which is quite boring, typical asphalt parking lot, most of the rainfall becomes runoff, are in these solid lines, okay? And each of the solid dots represents a separate storm through which that best fit line goes, okay? The dotted lines are the relationship for post-installation of the green infrastructure. So what we see here is a shift in the relationship between the amount of runoff coming off of the parking lot, a downward shift after we install bioretention, which is indicative of the fact that this bioretention cell is in fact abstracting runoff, holding it back, evapotranspiring some of it, infiltrating some of the rest of it before it discharges some of the water out to the storm sewer. Those of you who have been looking at the permeable pavement insets here, you're like, where did the dashed line go, right? There's no dashed line. You forgot the dashed line, Brian. Nope. In fact, the dashed line sits right underneath that solid line. So in other words, there was no effect whatsoever over the first 30 months after construction. We could not tell that the permeable pavement was there. Okay. Hydrologically, it made no difference because the run-on ratio was so high, the system clogged very quickly, and it just was unable to function. So again, please do not push the run-on ratio this high. Please, 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 please. It's not worth it. It will clog very quickly. All right, so based on this and some other studies that I'm not going to cover for lack of time, we've kind of come up with a recommended schedule of routine maintenance. So scheduled basic maintenance of porous pavement based on a lot of these studies that we've done, okay? Most of the design guidances that are out there from various states recommend a static maintenance frequency, once a year, twice a year, 4 times a year, regardless of what the engineer chooses as the particular design, okay? What we really recommend is relating this to run-on ratio because we think this is the critical factor for how fast these systems clog, okay? It's the primary factor. So for direct rainfall, we think maybe annually, 1-to-1, maybe twice a year, 2-to-1 quarterly. I'm going to be honest with you, beyond 2-to-1, I start getting nervous. And then as you go further right on that scale, I get very nervous, okay? You're going to have, the maintenance burden is going to be so high that I just would not recommend that you go there, okay? So that's why I have question marks out there. I'm not sure how frequently, but it's going to be way more frequently than you want as an owner, put it that way, okay? Another thing we've looked at is really other stimuli for clogging. There's obviously spatial heterogeneity within a permeable pavement. There's areas that have overhanging trees. There's areas that receive concentrated runoff. There's all sorts of different factors within a particular permeable pavement, okay? So what we did across a number of sites is we did testing on, let's say, Julian day 0, and then we came back 90 days later, one quarter of the year later, and did testing at those exact same locations across a number of porous pavements. We had locations that were controls where we expected there really weren't any stimuli for clogging. We had areas underneath trees, areas receiving concentrated flow, areas that received pervious contributions from pervious areas, like parking lot islands and the like that might be mulched or might have bare soil. What you can see is from the start to the end of that 90-day period, the control locations really didn't clog. There was a slight reduction in median surface infiltration rate, but they didn't clog much at all, okay? Where we saw significant loss of surface infiltration rate were under trees, areas that received concentrated runoff coming onto the pavement, areas that were receiving runoff from pervious locations like landscaped areas, and then at the PII, or the permeable impermeable interface. And I'll mention that in just a second, okay? So what I want to say here is these are areas that might take a little bit more focused maintenance, right? If you're going to come out and maintain twice a year, let's say, right, during those twice a year maintenance efforts, underneath trees, you may want to make 2 passes with your street sweeper as opposed to 1, okay? So those are the types of changes we might need to make in these small areas that might clog a bit more quickly, okay? So our overhanging trees, areas along curbs, where there's landscaped areas adjacent, those are areas where we've seen definite clogging at a quicker pace than the average across the porous pavement lot, across the parking lot. Unstable catchments upstream, so out parcels and active construction are difficult for porous pavements, and are, after those areas have been vegetated or construction is completed, you're almost certainly guaranteed to need restorative maintenance at that point. So major maintenance at that point. The permeable impermeable interface is another point where we see higher maintenance needs spatially within a porous pavement. This is a lot in Perkins Township near Sandusky. And you can see in the drive aisle of this particular parking lot, there's regular concrete. It's crowned as you typically do with the road. So the runoff is going to go off to either side into the pervious concrete in the parking stalls, okay? And what ends up happening here is that this permeable impermeable interface right here ends up acting sort of similar to a forebay in a pond or a bioretention cell or a wetland, okay? It's where all of the sediment accumulates. It's where that water first starts to infiltrate. And so the clogging will tend to migrate as a function of time. Okay, so this area is going to be an area of higher maintenance needs spatially. And you can see an example of this here in this picture during a rainstorm. Again, you can see a picture here of the permeable impermeable interface and the amount of just sediment that's accumulating in the joints between the bricks, just qualitatively. Okay. Concentrated flow paths are another one to watch out for. This is the retrofit at the Myers store that I mentioned earlier, 9 stalls of permeable pavement. Obviously, there was existing grades to the asphalt parking lot here. And so you can see there's a concentrated runoff path that enters the pavement here. And so certainly this part of the pavement was really hammered and quite quickly clogged, to be honest. So those concentrated flow paths, again, are areas where you might have higher maintenance needs, okay? So certain areas are susceptible, the landscape hardscape interface, the permeable impermeable interface, as I mentioned. And so really it's a question of what level of service do I desire as an owner or as someone who might be regulating the maintenance of these porous pavements, right? As civil engineers, we think about level of service as our desired or goal for how we want a system to function, right? So we really need to collect some hard and fast data in order to understand and plan for level of service, okay? So how do you measure how water flows through porous pavements? There are a number of quick and dirty methods that I'll show you in just a second. And then there's a couple of different infiltrometers that are out there that can be used to measure how fast water moves through a pavement, okay? The first thing I would recommend, honestly, is watching these systems during a rainstorm. Going out behind your windshield and looking at how they're functioning. If you see surface ponding during a rainstorm, that's an indication that you need not routine maintenance, but restorative maintenance, okay? You are at the point where you've got your pavement hydraulics have failed, essentially, or are on their way to failure, and you need to get out there and do some restorative maintenance. Bucket test, if you are there during dry periods, is another way to handle this. It's a 5-gallon bucket of water, pour it quickly onto the pavement. It should all infiltrate very quickly, right? If you start to see runoff like this or like this, those are indications that, again, you're probably going to need to schedule some restorative maintenance in the near future. If you want to quantify surface infiltration rate, there are a couple of methods that are out there. The American Society for Testing Materials has a methodology, either C1701 for pervious concrete or 1781 for PICP. And these are essentially taking a 12-inch diameter ring, affixing it to the pavement with plumber's putty, and pouring in water, 5 gallons of water, and keeping about a ½ an inch of constant head on the pavement surface. Which can be extremely challenging if you have a very, very high surface infiltration rate, nearly impossible, to be honest with you. And then on the other end of the spectrum, if you have a heavily clogged pavement, these can take very, very long time to run. Again, best handled by a graduate student with lots of time on their hands, 30 minutes or more if the system is heavily clogged. And again, the surface area that you're testing is only 12 inches in diameter, which is quite small and maybe not super representative of quite a large permeable pavement. So we came up with the simple infiltration test, which originally we called the shallow head infiltration test, but the acronym didn't quite work out. So we went with simple infiltration test instead. Essentially, you take a 2x4 wall stud, an 8-foot wall stud, you cut it into equal sections and screw it together, okay? And then you apply the same plumber's putty, force it down onto the pavement, and then pour 5 gallons of water into the infiltrometer. Measure how fast it infiltrates, and from there you can get a surface infiltration rate for your pavement. The surface area of this test is about 4 times larger than that for the single ring test that I showed you on the last slide. And so therefore the tests take about 3/4 less time in terms of duration that it takes to run the test. So that's a huge benefit in terms of being able to do a number of these quite quickly on a single permeable pavement. Okay, so what we generally recommend is on this slide, if it's less than 30 seconds for this simple infiltration test to infiltrate the entire 5 gallons of water, it's like new, it's working fine. Continue your routine maintenance as we talked about earlier. 30 to 60 seconds, again, routine maintenance is fine. We're getting closer to needing restorative. 60 to 90 seconds, we're probably talking about bringing out some of the bigger guns, right, for restorative maintenance. And then greater than 90 seconds certainly is clogged, okay? Again, thinking about this as a function of design a little bit here, we've also thought about, what are some minimum infiltration rates that we'd like to have for permeable pavements? And we could have half an hour discussion just around this if you wanted to. But what we're currently recommending is less than 10 inches per hour for permeable pavements treating only direct rainfall. That's the point at which we need to start doing restorative maintenance, okay? 1-to-1 run-on ratio, we really want a minimum of 50 inches per hour surface infiltration rate. And for 2-to-1, we really want 100 inches per hour or more. And that's because when you have runoff entering the permeable pavement, it has a velocity, right? It's not like direct rainfall where it has no velocity. And so you need a higher infiltration rate to essentially suck that water down into the cross section of the permeable pavement. All right, so some rules of thumb on measurement of surface infiltration rate. We think you should use the simple infiltration test about once a year, okay, to establish your restorative maintenance needs. Do you need to do restorative maintenance or not? That's essentially what we're recommending you use the simple infiltration test for, okay? What we recommend is about 5 surface infiltration rate tests, these wood square tests per half acre of permeable pavement. These take about 5 to 10 minutes each to do, so you're not talking about a tremendous investment in time. And if less than 20% of the lot comes back as clogged, then we say, okay, we're fine. Let's test this again next year and see whether we need to bring out some technique to do restorative maintenance, okay? Obviously, all of these recommendations and rules of thumb can be modified depending on your desired level of service, right? So if you really, really want this permeable pavement to function, then maybe this is 5%, right? And maybe this is 20 tests per half acre, right? So you could, this is a sliding scale, obviously, as a function of what your desired level of service is, okay? So you're like, all right, you spent the first 3/4 of this talk on showing me that maintenance is needed. Let's see what actually works out in the field for maintenance of permeable pavements. Okay, good housekeeping. First and foremost, absolutely keep your watershed clean, particularly if there's construction. Street sweeper is best method for that, right? Keep the sediment off of the permeable pavement. Blowing off leaves and debris, particularly in the autumn from deciduous trees, acorns, etc., is also important to keep them from being ground into the porous pavement. One of the sidebars before I show you some of the maintenance techniques is really trying to understand where in the cross section do these permeable pavements clog. Okay, so this is a slide courtesy of Bill Selbig, who I know has spoken with y'all before in this series. And we've actually done a little bit of work, as I'll show you at the end of this talk, on where in the profile of the pavement does it clog. And what's generally known in the literature or accepted in the literature is that it clogs, these systems clog in the upper 1 inch of the cross section, okay? And that's nice, right? Because then we can get some sort of technique in there to remove that clogging material. If it's deeper, right, the deeper it gets, the harder it is to remediate. Okay, so I'm going to come back to this point of 1 inch depth of clogging a couple of times as we go through these maintenance techniques. Okay, so you'll see we tested a bunch of maintenance techniques. We used this ASTM 12-inch diameter ring to do these maintenance tests. Okay, so we measured existing pavement hydraulics at 3 to 6 locations on each permeable pavement before maintenance. Then generally that afternoon did the maintenance, and then the next morning came out and did post-maintenance infiltration testing at the exact same location. So we could look at a particular location pre versus post, okay? So you'll see a number of box plots in the next slides that compare pre to post, and these were the methodologies that we used to collect those data, okay? So the first technique we used was we removed the upper 3/4 of an inch of clogging material. You can see from a PICP here using a screwdriver. Again, best done by a graduate student to simulate removal of the upper 3/4 of an inch of clogging material. Okay, we did this in Sweden, so some awesome street names like Faxtusgatan and Schwerenwagen, all sorts of cool Swedish names. And what you can see pre versus post here is that pre-post, not a lot of difference, not a lot of improvements in the median value, these dark lines in the box plots, right? So you would expect that if all the clogging material is occurring in that upper inch, if you remove the upper 3/4 of an inch, you probably remove most of the clogging material. So what happened? Well, if you look at this picture here, you're like, that doesn't look like gravel. That looks like soil. And in fact, that's because it is soil, okay? It was built wrong And all of these 4 streets had soil put into the interstitial spaces as opposed to the typical gravel that goes into these pore spaces between the bricks. So if you build it wrong, you will not be able to do routine maintenance and fix it, right? So this is an error in not doing construction oversight as you're building these systems, okay? We also in Sweden did work looking at vacuuming, handheld vacuuming in this case as a proxy for larger vacuums, pressure washing, and then the combination of the two, which I'm going to call VP, not vice president, but vacuuming plus pressure washing, okay? So we did this in Luleå, vacuuming, pressure washing, and the sum of the two, and then vacuuming, pressure washing, the sum of the two in Haparanda. These were on the porous asphalt roads that I showed you earlier in Sweden, quite old. We pressure washed at a 30-degree angle. Obviously, you don't want to pressure wash straight down as you'll push the clogging material deeper into the pavement. And what we found generally is that the vacuuming treatments did significantly improve the surface infiltration rate. They worked, okay? But anything with pressure washing was significantly better than vacuuming alone, okay? So the pressure washing seems to dislodge the material better than just vacuuming alone. And one thing I want to be clear on is I think this is the direction that a lot of the technologies for permeable pavement maintenance are going. The combination of vacuuming and pressure washing on like a gator or a golf cart sized vehicle to do this maintenance on large areas. All right, we tried milling porous asphalt with an M, okay? If you look at your keyboard below you, since we're all virtual today, you could see that if you replace the letter M with the letter K, you might get a slightly worse word than milling. You would in fact get killing, right? So this is my best email chain I've ever been involved in. Gentlemen, I have bad news. I stopped by Galmelstad 10 minutes ago and the killing had not been completed. I will see you tomorrow at the building at Luleå Technical University. Cheers, Ryan. The killing, quite dangerous in Galmelstad at nighttime. Yeah, so autocorrect definitely got me here on my iPhone and switched milling to killing. Luckily, before I got this email, I had made it back through TSA from Sweden to the US without any, search of my person for sending emails about killing when I meant to send an email about milling. Okay, so what we did was we milled the porous asphalt streets to 2/10 of an inch, 1/2 inch, and 1 inch depths to try to see how deep did we need to mill the porous asphalt before we saw improvements in surface infiltration rate. If you've never seen a milling machine, this is what it looks like. It's essentially a large drum with teeth on it that grinds up the pavement, okay? So pre-maintenance, the system was heavily clogged, okay? We took off the upper 2/10 of an inch and we got back about 80% of the newly constructed surface infiltration rate back in 1994, taking off the upper 2/10 of an inch of pavement. So again, that does suggest the vast majority of clogging is occurring right near the surface, okay? 1/2 an inch, slightly better. 1 inch depth got us to within spitting distance of brand new, okay? To within 10% of brand new, all right? So really, we do think that in the upper inch of porous asphalt, we are seeing the vast majority of the clogging material accumulate, which is a good thing when it comes to being able to remediate that clogging material. We've also looked at a number of different sweepers, and these run the gamut from just having bristles to having some sort of suction, as I'll show you in just a second. Obviously, we've all seen traditional broom sweepers. These typically have bristles and a drum that sucks the accumulated debris and material up into the hopper. We've also tried regenerative air street sweepers. These are interesting devices in that they have a blower and they blow air down onto the pavement surface, and then they have suction on the other side of the boom underneath the truck, okay? So again, a blower to force air down and try to lift material off of the pavement surface and then suction on the other side, okay? So what we saw at a test at a highly clogged site in North Carolina, this is pre-maintenance, after we came through with 5 passes of a mechanical street sweeper, we roughly doubled the surface infiltration rate. So that mechanical sweeper does work to some extent, particularly for preventative maintenance, but it's not going to restore pavement hydraulics if it's heavily clogged, okay? Came back in the next day with a regenerative air street sweeper, 3 passes of that. And you can see again, roughly 8-fold higher surface infiltration rates here. So substantial improvements and much better function for removal of clogging material when we have that added suction component. So regenerative air And standard bristle street sweepers work for routine maintenance, but they're not going to fully restore. They're not going to be restorative types of techniques, okay? And that's because, particularly for the bristle street sweepers, the bristles can't get down into the pore spaces. They get stuck on the surface, so they're just able to remediate the surface clogging material. We've also looked at using a vacuum truck, which is like your home vacuum on steroids. The Eldred Megawind is one example, but there's many others out there on the market. These systems work quite well for restorative maintenance. They have a tremendous amount of suction and can lift an inch or two of material out of the pavement. So you can see pre-maintenance here in 2014, post-maintenance got to back within spitting distance of new, 500 inches per hour, clogged again after another year of functioning, and we got again back to close to new after maintenance with the vacuum truck. So we do think the vacuum truck is quite good for restorative maintenance particularly. I want to close with some thoughts on maintenance testing on PICP that we've done more recently. We've tested just standard pressure washing, which does work quite well. The only problem with this is it kind of translocates or moves the sediment plume around. So if you don't have any way to suck up the material that's been moved by the pressure washer, this is not going to work all that well, okay? Some techniques that I think have more interest are this rejuvenator and this machine cleaning vehicle here. These both combine high pressure washing and suction, in this case from a regenerative air street sweeper that this is attached to, and in this case from a vacuum that's inherent to this, this Gator type vehicle, okay? So I think these types of machines are the way that the technologies are heading for permeable pavement maintenance. We did this testing at a number of actual curb-to-curb permeable pavement streets here in Columbus. And so we tested these across a number of different locations on these streets. And I just want to highlight some of the takeaways of our findings here in this rather complex graphic that I'll walk you through. We did find that pressure washing from pre to post maintenance roughly doubled our surface infiltration rates. Again, if you don't have some sort of vacuuming to go with that pressure washing, there's no way to remove that dirty water from the pavement. And so I wouldn't recommend pressure washing on its own. You do need some sort of wet dry vac to vacuum up the dirty water. Any sort of vehicle that included pressure washing and vacuuming together, so the rejuvenator and the machine cleaning vehicle, which is abbreviated here as MCV, they all improved the pavement hydraulics significantly. So we really think that those types of vehicles are very good for restorative maintenance of highly clogged pavements, okay? Regenerative air street sweepers, we tested on these pavements. These pavements were actually decently clogged at the point at which we got to them. And the regenerative air street sweepers really didn't work all that well for clogged pavements. They're fine for routine maintenance. They don't work great for restorative, which is what we were really trying to test here. The last point I want to make is this one regenerative air test that we did where we actually saw a decline in surface infiltration rate after maintenance. Okay, we saw about roughly half the surface infiltration rate after maintenance. And you might ask, why would we see a reduction in the pavement hydraulics? And so I'll show you a picture of when this maintenance was done and actually a short video as well. So you can see the street sweeper here. This is a regenerative air street sweeper. Applying suction to the pavement surface here. And one of the challenges that we had in the picture that you see is that the pavement was actually wet when this was being done, okay? So what we think was happening is the blower here may have actually been blowing or forcing air down onto the pavement and actually consolidating some of that wet material that's in the pavement. So what we're recommending generally is avoiding maintenance of these pavements when they're wet, because we think that clogging material is going to be sort of congealed or held together better than when it is dry. Okay. Last few slides here. We also saw for the machine cleaning vehicle that it didn't work quite as well as what we had expected to see. So we saw about 120% increase in infiltration rates after maintenance. The manufacturer, manufacturers can report whatever they want, but their reported tests were much better than ours. So we did a little bit of CSI and actually took some of the bricks out and looked at what was happening in the pore spaces between the bricks. What you can actually see is that some of the sediment, you can actually see the outlines of the bricks that we've removed here. So some of the sediment's actually getting down quite deep into the cross section. And so that's one of the reasons why we think some of the techniques that we studied here in Columbus didn't work as well, is because the owner of these pavements, when they did maintenance, they didn't come in and put new stone between the bricks after the maintenance. And so the issue there is that you end up with an air gap right below the pavement surface. And then the clogging material goes deeper and deeper each time you maintain. If you don't put new stone in, the clogging material goes deeper and deeper, and it becomes harder and harder and harder to remediate. Okay, so I'm going to move through this slide quite quickly, but just to say here that we've measured infiltration rate as a function of the depth of clogging material that we've removed. So we've measured infiltration rate before we removed any material. We removed about 0.8 of an inch of material, 1.6 inches, and then we actually removed the bricks altogether. They're about 3 1/8 inches thick. And what you can see here on the bottom, the median infiltration rates really didn't increase with only an inch of removal, suggesting here that because we hadn't added new chipstone after maintenance, that the clogging material was actually quite a bit deeper than 1 inch. So we did see some improvement when we got down to about 2 inches or 1.5 inches of debris removal depth. But it wasn't until we had actually removed the entire brick that we saw like new function of these porous pavements. So again, when you are maintaining, particularly for PICP, where we have this small gravel between the bricks, you absolutely have to re-chip it after restorative maintenance when you've removed some of that chipstone, okay? So what we would recommend is removing your joint material, your clogging material, to about 1 to 2 inches below the pavement surface, and then coming in with new chipstone immediately after and brushing it in. Obviously, this is a small scale application. You typically do this with a skid steer loader with a broom on it for a larger scale application. Last slide here, number of maintenance passes do absolutely matter. The more passes you do, the more times you go over the same spot, the more material you remove, the more clogging material you remove. So what you want to be careful with here is to visually identify how deep the clogging material has been removed, right? So if you've removed 1 to 2 inches, that's what we want to shoot for when we're doing maintenance. If you start removing more than 3 inches, you could actually undermine your pavement structurally, right? So visually, you want to have someone looking after a pass. You want to take a look at the pavement, see how much has been removed, and then come back through with another pass with whatever your restorative maintenance technique is to ensure that you've removed enough material. For routine maintenance, this really is not important. This is really just for restorative maintenance where, again, we should be trying to really remove some of that material that's been clogged in the pavement profile, okay? So for routine maintenance, we can just move through quite quickly. This is, I think, only important for restorative techniques. So maintenance methods, we think all of the ones that are shown here work quite well. Regenerative air street sweepers, pressure washing, even bristle street sweepers for routine maintenance are just fine. And then really you need bigger techniques for restorative maintenance. So something with a large amount of vacuuming, like a vacuum truck, or the combination of pressure washing and vacuuming, I think is where the industry is headed for restoring the function of systems that are heavily clogged. So maintenance considerations, design for maintainability is absolutely important. Limit your sources of sediment. Higher run-on is going to be more frequent maintenance. So thinking about maintenance during design is absolutely critical in my opinion. Keep up with your good housekeeping and routine maintenance. Have a plan for that from the start. Use the surface infiltration, simple infiltration test to schedule your major maintenance, your non-routine maintenance. And again, the market is really burgeoning with new devices that are out there, new techniques. So I think there's a lot more to come in this area to try to understand how we can best maintain these systems. So I'd just like to acknowledge some students that I've worked with in the past, some coworkers, and a lot of different funding sources that in a variety of different ways have helped to move this work forward over the last decade. With that, I'll leave you with my two favorite street sweepers, Dustin Timberlake and Bruce Springclean from London, UK. Did steal this one off the internet. If you want more information, feel free to reach out to me via email. We'll have a lot of great discussion over the next hour as well. So thank you very much for having me.
Thank you, Ryan. That was 15 years. Is a long time, but there's a lot that's been learned, and it seems like there's a lot to learn. So we have quite a few questions. The first one is from Randy Niepresh. He says, do you see different rates of clogging between various types of pervious pavements, porous asphalt, porous concrete, and pavers with gravel in the spaces between the pavers? And I'm also interested in some of the pavers that don't have the requirement to put anything in between them. And do you have a recommendation for which type of pervious paving is best for performance and maintenance?
Okay. Wow. Really loaded questions there, and really, I think a fantastic question or questions. So comparing between, let's say, porous asphalt, pervious concrete, and pavers, I think there's a couple of things that I like to think about, and most of them are actually not maintenance related. To me, I like to be a little bit conservative as an engineer. I like to have a product that comes to my construction site, comes off a pallet, boom, it goes in the ground, and it's good, right? It's good to go. Concrete and asphalt, as we know as civil engineers, are a chemistry effort, right? There's water to cement ratios we have to care about. There's all sorts of factors that go into whether you get the product you want at the end of the day, okay? There's also lots of different additives that can be added to things like asphalt mixtures, add mixtures to them that makes the system a lot more complex. So what we see in Central Ohio particularly is a lot of pavers going in the ground. There's about 1 million square feet in design here at any one time. Asphalt plants and concrete plants generally here anyhow are very interested in traditional asphalt and traditional concrete because that's what they've sold for many years. And they're not interested in shutting down their plant for a couple of days to do a small batch for you. So for that reason, we don't see a lot of pervious concrete and a lot of porous asphalt locally. And so I don't know that I can answer your question, to be honest with you, related to which one works better as far as clogging goes. Which one clogs the least, I guess is the way that you posed it. I think they all clog, and I think that's mainly related to this run-on ratio, right? And so being smart with your design up front and reducing that run-on ratio as much as possible, or if you want to have a high run-on ratio, and let's say you're routing a building rooftop into the system, route it into the subgrade, right? You don't need to route it onto the surface. You can use kind of like a reverse French drain system and get roof runoff into the bottom of your permeable pavement, right? Into the subgrade. So I think really the other piece of the question was sort of the pave drain type of product, or the one where you don't have any gravel in the interstitial spaces. I do not have a lot of experience with that. I'll just be upfront with you. We don't have a lot of applications of it in Ohio, and we didn't in North Carolina when I was there either. I've always had some concerns with, the ability for clogging material to just get down into it. And then those bricks are something like 6 inches thick. And so, I think others may be able to speak better to the long-term maintenance needs of those than me, though, given my lack of experience with those pavements.
Okay, great. So the next question is from Mike Trojan. Does the type of maintenance differ with the material being removed? I'm specifically thinking about organic debris, which could get ground up and make things worse if cleaning is not done correctly.
Yeah, good question, Mike. So what we've seen, I think to answer your question, what we've seen here is that there's 2 times of year that are most important, most critical to do maintenance on porous pavements. And I think they'd be very similar in Minnesota, given that your climate is maybe colder than ours, but still has winter de-icing, et cetera. So those times are the autumn, as I mentioned, right? When all that organic debris does tend to get ground up. So we usually recommend kind of a pre-winter maintenance, the end of autumn, early winter timeframe as a key time to maintain, to get that organic debris out. And then actually we recommend typically just immediately post-winter, because we see a lot of sediment and grit being created from the friction that's applied by the plow blades in the wintertime, right? And snow melt does tend to be very dirty. And so again, if we're gonna schedule routine maintenance, let's say a minimum twice a year, we would recommend kind of early spring and late fall. And we think that those are the optimal times if you're gonna only do 2 routine maintenances to do them in the year.
Okay, we have a question from Tom Ritzer. The question is run-on ratio only to impervious to impermeable, or do you include adjacent green space sloped towards the permeable surface?
Yeah, it's a good question. I believe it depends on the state. I think here in Ohio, you're allowed 2-to-1, and that is regardless of percent imperviousness. So it's just watershed area to the surface area of the pavement. Certainly, if you have a well-vegetated pervious area, I think that's just fine, right? If you've got a parking lot island that hasn't been maintained in a commercial parking lot in 10 years, as we know some parking lot islands are, that might be a significant source of sediment. So you really need to think about what's actually in your watershed. How likely is the landscape maintenance crew to create a source of sediment, essentially? So yeah, at least in Ohio, they count the run-on ratio the same, regardless of whether the watershed is highly impervious or highly pervious.
Okay, this question is from Dan Christian. Are you able to place new porous asphalt after milling, especially to the 1-inch level? Are there any problems or lessons learned?
Yeah, hi Dan, good to hear from you. Yeah, it's a great question. I've never done it. I've never done it, as the answer to your question. So I would imagine, so typically when you mill off the upper layer of a hot mix asphalt street, you have to come in with a binder to bind the base course of the asphalt to the new wearing course that you're going to install. And that binder, obviously, if that was something you had to do with porous asphalt, that binder could potentially play a role in reducing the ability of water to move through the pavement, right? So it's not something I've ever done, Dan. We can just tell you that if you mill it, it works. For restorative maintenance, I think we still need to close the loop on, yeah, how do we bring the final grade of the street back up to where it was supposed to be, or to where it originally was.
Okay, we have one more question that I've been saving. Finish this, and that would be from Ross Bittner. His question is, do you have a sense for the cost of management? I just lost it. Oh yeah. Do you have a sense for the cost of maintenance? Could you compare the marginal cost of maintenance versus the run-on ratio decision to find an optimal lifestyle cost benefit? He's not asking.
He's not asking for much. That's right. No, it's a great question. So my general take on this is that the maintenance costs are a relatively small fraction of the upfront costs to construct the facility in the first place. I've actually been floored when we've worked with private companies locally to get them out to maintain porous pavements for our experiments, how cheap it is. I mean, we had them on site recently for an hour, and it was like $120. I mean, it's not tremendously expensive to get a private company to do street sweeping. That's what they're in the business to do, right? And that's what they do all day. Particularly if these systems are in a downtown area or in an area that's being swept anyway, the marginal increase in cost may be very, very low. But I would estimate maintenance costs to be, let's say, 1 to 5% of initial construction costs per year. The restorative maintenance is, especially with interlocking concrete pavements where you have that chipstone, is going to be a bit higher because you need to bring new chipstone in from the quarry. So there's some trucking there and some labor, but it typically is not as high a cost as I was expecting. Anyhow.
Okay, thank you, Ryan. I'll give you a one-person applause. That was a great presentation. We will break for 5 minutes. I'm already into Andy Erickson's time. Andy will be back with the panel and he'll lead a panel discussion. So we'll be back in about 5 minutes at 11:04.
Hello and welcome back to the Minnesota Stormwater Seminar Series. We will now start the panel discussion. It is my honor to introduce our panelists today, our local panelists, who have graciously agreed to serve as panelists on this topic this morning of permeable pavements. Our first panelist is Craig Eldred, who is the Public Services Director for the City of Waconia. So Craig, from your experience and perspective, how do you relate to this topic?
Well, thanks for having me, Andy. basically, we have been involved with permeable pavements here in Waconia since 2014. I've had a little bit of previous experience with some paver strips where I worked before. And then this year we're actually installing a turf parking lot for the first time. It's a little different process, but we actually do utilize pave drain for a lot of our projects. So we really like the product, and a lot of work with our engineers on design, and then making sure we're trying to get our outcomes to be manageable and what we're looking for our community. It's really the impacts I have.
That's great, Craig. Thank you. Our next panelist is Paige Ahlborg, who is a watershed project manager for Ramsey, Washington Metro Watershed District. So Paige, from your experience and perspective, how do you relate to this topic?
Yeah, hi, Andy. So like Andy said, I'm with the Watershed District. And for those of you who aren't familiar with watershed districts, we are a local unit of government tasked with stormwater management, and we have a permit program and a grant program that through the permit program, people are required to put in stormwater BMPs. And then through our grant program, we help fund the cost of those not required by through a permit. And we're seeing a lot of porous pavements go in through that, and seeing maintenance as a constant struggle as part of that.
That's great, Paige. Thank you so much. Our next panelist is Allison Bell, who is the Green Infrastructure Coordinator at the City of Minneapolis. Allison, from your experience and perspective, how do you relate to this topic?
Hi, everyone. So as Andy mentioned, I work for the City of Minneapolis, which is obviously a fully developed urban environment. Interestingly, historically, the city hasn't had any stormwater requirements that have led to the city needing to install green infrastructure or permeable pavement. So all of our kind of more typical installations have been on a more voluntary basis, which I think is kind of a unique factor. We did try permeable pavement about 10 years ago, so we were a little ahead of our time and a little ahead of the science. So we had a little bit of a bumpy road. We also started with some of the products that Ryan mentioned might cause a little more headaches and require a little more science. So as we move forward, we have a growing voluntary program based on basically calls from the community to do so, which is very encouraging. But we've also implemented a new stormwater ordinance. So pretty soon moving forward, we'll be required to add a lot of stormwater into our transportation projects. So as a result of that, we see permeable pavement as a really important tool that we basically are going to be required to get a little more creative in our space with our competing space, especially in downtown areas and places where we're competing for every inch. So I'd say we're still we're really more focused on the planning design, and as we move forward, we'll be focusing on how we can look at our maintenance program as well.
That's great. Thanks, Allison. I will not ask for Ryan's relation because he gave the keynote and it was a great presentation. I do want to thank the audience for your great questions. We have a lot of really good questions still in the Q&A box. If you have questions for our panel discussion, please post them in the Q&A and add a thumbs up to the ones that you agree with and you want us to ask. I will be pulling from the Q&A that came in during Ryan's talk because I think it's really good to get the local Minnesota perspective on some of these questions. But before I jump into those, I do want to get to start the panel, an idea from our panelists about what are the most important benefits of using permeable pavements in our urban landscapes in Minnesota and beyond, if you have perspectives beyond Minnesota as well. So please share what you think are the important benefits. We heard Ryan's perspective. I want to hear from the local perspective. What are you getting out of having these in our urban landscapes? And anybody can jump in.
I can start. I think Allison kind of touched on it, though. What we see as a good benefit is that, our developments are happening in very tight locations now. They don't have room to put in large infiltration basins or even underground systems, which are fairly expensive. But this using porous pavements can, meet the permit needs as well as offer something usable. Obviously, everyone needs a parking lot, and that's what we're seeing more and more these days for needing reconstruction. And then also wetlands are a big thing. So places that a lot of our open spaces that are needing to be or in position to be redeveloped have wetlands on them. So properties need to maintain those buffers and whatnot. So having their parking lot be porous alleviates the need for another stormwater BMP that might infringe upon that wetland zone or the wetland buffer.
And of course, I echo what Paige said, because she echoed what I said. But so that it really is the key for us is, you know, it's not it gets us away from a no, where, you know, space is no longer, you know, the excuse that we can really use the space twice. And I'm looking forward to in the future, especially as we get better at our operations and maintenance in the winter time, that we can start realizing the benefits of how these perform in the winter, reducing ice and needing less salt and sand. So I'm really looking forward to that as we move forward.
Yeah, I could touch a little bit on the maintenance part, specifically with the, like Allison mentioned, our staff, we get away from using salt on these areas. It's really critical to have the proper cleaning equipment, so we use a lot of rubber edges, poly, cutting edges for our plows, but not having to use chlorides is huge. With our system, we do have that split ratio like Ryan had talked about today quite a bit. And so you really got to kind of watch where you do apply chlorides, because it can have an impact to your product as well. So, and we are pushing a lot of things towards our residential areas as well. So we're looking at permeable driveways for a lot of our residents to make sure they're getting underneath that restrictions when they're near those critical watersheds as well.
Ryan, did you have anything to add or no?
Yeah, I would just say, you know, I echo what everyone else had to say, and I think that City of Columbus is in very much the same driver's seat as Minneapolis, where we've got SSO and CSO problems in neighborhoods across the city for which the city is under a consent decree, and so, you know, permeable pavement rises to the top in a lot of cases, because in some of the previous retrofits of stormwater controls that have been done by the city, they've had to take away parts of people's front yards, even though it's in the quote unquote right of way. Those neighbors see that as their front yard, right? And so if you put a bioretention facility there, you know, you can have there's a lot of NIMBYs that are really mad about that. You know, about 50% of the people are really mad about that. And so in future retrofits in the city, they're really looking to permeable pavement as one of the key cogs in their control strategies.
I can certainly see that. Yeah. So I'm going to jump in and grab a question actually out of the Q&A panel, because it actually leads very well into the question I was going to ask about challenges and barriers and limitations. And the question comes from Lisa, and it says, it sounds like some of this work was done in cold climates. But in general, how do environments with extreme freeze-thaw conditions, heavy snowplow use, road salt, impact the performance and the longevity of these permeable pavements? And I know our panelists probably have some experience here. I also know that New Hampshire has done a lot of work with permeable pavements in cold climates, so I encourage you to check out for those resources as well. But what do our panelists have to say about having these pavements in our cold Minnesota climates?
I can speak from how I know they should perform and how they typically can perform, especially, you know, in the research that you know, given the freeze-thaw cycle, that structurally we should be seeing better performance. So when they're installed correctly with the right materials, that's a huge benefit. Less maintenance down the road. Of course, with a, you know, something like a unit paver system too, you're typically seeing less surface maintenance anyways, because you have that flexibility in the surface without cracking. And again, that's about as far as I can go, just because we don't really have a robust set of permeable pavement yet. But again, we are looking forward to that being a vital selling point to why it's such an important product to be using in the city.
Yeah, I'll echo what Allison had to say. I think the freeze thaw issue is really, like I said, I've seen these systems as close as like 40 kilometers from the Arctic Circle, right? So well north of y'all, even in Minnesota, where it is quite cold, right? I know it's cold in Minnesota. And they look great. They the porous asphalts that I saw were 20 years old. They were clogged from lack of maintenance, but in terms of the structure, they're still there, and they're still, there's no frost heave. I know UNH has done work. We've also done work on having temperature gauges in the subgrade beneath the pavement surface, and we've really never ever seen freezing here in Ohio. I realize it is a bit colder in Minnesota, but even if you do get freezing, the nice thing about the open graded aggregate underneath permeable pavement is there's space for that water to expand out into, right? Whereas a dense graded aggregate underneath a typical sidewalk or road, it's just going to heave, right? There's nowhere for the ice to go. So.
Yeah, we've seen good luck with it in the winter. We've used a number of different types, the porous asphalt, paved drains, different porous pavers. They can be plowed pretty much like normal. The issues we've seen is maybe, I think someone mentioned here with the installation, if some of the pavers maybe are a little bit dislodged or something and the plow hits those, but those can be easily replaced. What we try to do on ours, we have a porous asphalt lot at our office parking lot, is make sure that it gets plowed right away before people drive on it, because then driving on it creates just compacted snow and ice, and that's a little bit harder to melt. But as long as you can get the plow on there, get that snow off of there, we don't need the salt on there, and then it's not slippery. You get a little extra friction on there too.
Yeah, on our end, it's the same way. I mean, we don't see any problems with the movement of the product. So we have it in several different types of applications, and it's a very, very good product to work with. And don't see any heaving. There may be a few minor things that you might, like Paige mentioned, it might be a dislodge or something, but it's really easy to put the material back.
Yeah, that's great. And that's, I would echo that too. We've done some work with permeable pavements research wise, and done surveys and talked to different districts and cities that have had them. And that's been the message overall, is that we really don't see anything different between a permeable pavement and a conventional pavement in terms of frost heave. We don't see any more than we normally see. We don't see any issues with plowing any more than we would see on other pavements. So that's good to hear. And again, we can have more input on that. There's a lot of pavements around. We did a survey of cities, found something like 40 some different sites with permeable pavements around the Twin Cities metropolitan area. So there is a wealth of information out there if you want to get more of the local perspective. So one of the questions that came up, Brian, I want to jump back just to some of the questions that came in during your presentation and expand that to the panel. And that was the question about cost of maintenance and the marginal costs of maintenance versus the run-on ratio. And for those on the local panel, what are you tracking for maintenance and costs and effort? How often are you sweeping? Are you doing anything different? Do you want to do anything different now that you've seen Ryan's talk? So chime in on that, maintenance and really operation of these permeable pavements from the local perspective.
Well, I can jump in. I don't know if I can add a lot about the exact costs, but what we try to tell people is that if you put in a large infiltration basin or an underground system, you're going to have to maintain that as well. So looking at those numbers, comparing what you have there, and we do require an operation and maintenance plan for everyone who puts in these, so that so they know going into it what maintenance is going to hold, and making sure that not only the designing engineers know about this maintenance plan, but making sure the site owners will know about it, know what needs to go into that this is a little bit different project. And we're trying to make sure, they have the right equipment. And I did, I made lots of notes from Ryan's presentation, but one thing, I don't know how many people are doing the multiple passes with the sweepers. So I think that's important. You do, your 1 or 2 drive-bys, it looks clean, that's good enough. So I think that's definitely something we'll have to add in. But again, making sure they get that at least early spring and late fall sweeping. I don't know how often that happens on a lot of our sites. I know for sure they do typically 1 sweeping, but getting those multiple times a year in is important.
And for Minneapolis, like I said, we don't have a ton right now in the ground. So of course, private developments have their own operation and maintenance plan, which we do require. We so far have mostly had to contract out when we have maintenance of pavers. And we've seen some stumbles and some lessons learned in that contracting out process. But we did find that, basically an ignored installation in a downtown area after, years and years and years of clogging, we were able to restore it to what we wanted to see using a contractor. But for me, the really important thing, and Ryan spoke to this, which speaks to my heart, that through every phase of planning, design, construction, operations, maintenance has to be in there. So there's definitely, of course, ways to plan and design to reduce your maintenance or to match your anticipated maintenance to what your departments can do or what you can budget for to contract out. So of course, there's ways, do you have a really invested store owner adjacent to the property that says he's going to go sweep it every single day? Well, then that's going to obviously reduce your maintenance costs. You probably will never have to hire a vac truck. Or are you planning to ignore it for 10 years, in which case you should start budgeting for a vacuum truck to come in there. And then just making sure to keep that documented, that as you are building your maintenance needs over time, to make sure that you're not messing with your capacity and that you're not putting in anything that your staff can't physically handle because you're putting in too much for your FTEs, or that they literally don't have the equipment for, of course. So in which case you have to make that balance. So.
Yeah, from an operations standpoint, from us, we went almost 6 years by not touching some paved drain, and we bought a vacuum unit. It was always swept with a regenerative air about 3 to 4 times a year. But that vacuum unit, as Ryan mentioned, the material the water comes across, that 4 or 5 feet captures most of that sediment. And target with the staff last year on that system was 250 feet long. They spent about a day and a half, but they also measured all the way across in different segments of that parking lot to get some good data, because that's not something that we had done previously. And we saw cross axis of that area across that 250 feet where there was next to where the discharge was, where the inflow came, we were able to get that filtration component back just by using a vacuum unit with a pressure head in the water. So maintenance is very critical. Sweepers are good, but I think having that extra tool that we just acquired, we utilize grant funds from our WMO to do that, but we also signed on that if an organization in our county wanted to clean some paved drain, we'd assist them in that. So we saw some great benefits by having both applications to, remediate issues on our permeable pavement.
Yeah, I just want to echo something that Craig said, because I think it's really well said and important as well. And that was related to collecting a little bit of data. I don't think you need a lot of data to inform yourself. And so I think, based on the design run-on ratio, you can kind of get an idea of rough routine maintenance, right? But really the costs are going to be in those day and a half efforts that Craig mentioned, right? The non-routine rehabilitative maintenance. And so if you do something like the simple infiltration test or the ASTM test, once a year, once every other year, get yourself some idea of how quickly that clogging is starting to occur, because each parking lot's going to be slightly different, right? And then you can project into your maintenance budget, hey, we think in a couple of years, that's about when we're going to need to do restorative maintenance, right? Otherwise, you end up with a big bill on your plate, and that's unexpected. Right? So I think that's an important point.
Yeah, thanks for that, Ryan. That's actually a perfect segue into the next question I wanted to ask the panel. Given that recommendation of doing measurements annually for the infiltration rate, is anybody on the panel doing any kind of infiltration measurements on their pavements? What kind of testing are you doing if you're doing infiltration measurements? And if you aren't, why not? Are there barriers, or is it just not something that's been considered? Do you not have the staff time and training to be able to do that? So what about testing? What can you tell us?
We do it every year. No, just kidding. That is one thing. So we've done it on our office parking lot that I mentioned. We've had someone I saw in the Q&A mention having some issues with that, using that plumber's putty around the device. We had a lot of leaking
a pain.
issues. Yeah. But we have done that mainly when we've, maybe a little bit too late in the process where we've seen a lot of issues with drainage. So we were trying to find the spots that were having the most issues. So we have tried that. We do annual inspections on all of the porous pavements that go in our districts through our permit program and our cost share grant program, but we don't have the time or the staffing to do infiltration tests on them. So usually that's just a visual with the common note on their maintenance plan to do maintenance.
So we do them all the time for research purposes, obviously, Andy. So that's a bit of an unfair answer, but just to piggyback onto Paige's thought there, the plumber's putty can be a pain in the butt. I will freely admit that. What I would recommend, particularly for that simple infiltration test, you've got that 2x4 wood square. If you get two stout gentlemen to stand on top of them, and then a third person to pour the water, you can generally reduce the leaks substantially. So.
Just to provide an answer for Minneapolis, we're building capacity to have inspections on our publicly owned projects. We do inspections on private from time to time. But for our publicly owned, we will have inspections and we'll have requirements, to uphold depending on basically the level of service. So was that installation put in to meet the water quality or the rate control or, alleviate some local flooding? And then kind of marrying that with what we need to do for maintenance to, keep it within reasonable costs, but still doing what we expected and needed to do in the future.
Yeah, and I think another big thing for us is going to be how we do that measurement and maybe try to get some benefit out of our MS4 in the future as well. So that's going to be, we got several TMDLs to deal with, and trying to get those measurables is going to be more critical as we move forward. But permeable pavements for us, we're looking at that rate, the volume issues, and having the projects that we do have are important for lake water quality around us as well. So we see a huge benefit in the process, and we do try to measure what we can. So we've been at it for a couple of years with the permeable pavements, and I think we finally have a system that we're probably going to get set into our policy for that measurable.
Yeah, that's great. And that actually leads into the other question I want to expand on, that visual assessment. There was a question that came in from Ross Bittner asking, do you have any sample photos of varying stages of wear and or clogging? Are there any visual methods that can approximate or guide testing? Or maybe if I expand that a little bit, what do we think the infiltration rate might be just from some of the visual indicators or clues? So what do our panel and Ryan have to say about that? Ryan, you've seen a lot of different types of pavement at different stages of clogging. So is there anything that's, visually evident that maybe is easy to do compared to some of the infiltration testing?
Yeah, it's a great question. I think the one that stands out for me from memory is any place where snow has been stored in the wintertime, where you've plowed a snow pile, in your, we'll pick a Minnesota store, in your Target parking lot, right? Let's say your entire Target parking lot is permeable pavement. If you've plowed it all to one corner, I can absolutely guarantee you that corner is going to be heavily clogged by the end of winter. So one of the key things that I didn't mention is we always recommend to try to get the snow off of the permeable pavement over the back of curb as much as you can, to prevent snow's just full of dirt and debris. So that's, if you can see that kind of grit on the surface, that's usually an indicator that the infiltration rates are fairly low.
One other visual we've seen in the porous asphalt is that where it our tires are, or our cars are parked and you back up and turn your tires a lot, you can visually see where that's wearing down and becoming clogged. And then you can see either standing water after or during a rain event, or you can see the water flowing down to other areas where it's still soaking in. But yeah, as far as other inspections, we look for what Ryan said on other properties. And then, yeah, mainly just if we can get out there after a rainstorm and see any standing water or any very noticeable debris.
Yeah, I agree with the puddling. I mentioned that in my talk, and I think that's a really important one as well. That's an easy one to do visually, and that's usually a good indicator of, okay, that spot or the whole parking lot needs maintenance.
And even on top of that, this is, slightly different answer to the question, but in terms of the puddling, whether that also helps obviously identify that there's potentially a structural issue. So where there's rutting from the cars, and that might lead you to perhaps perform surface maintenance, because that could be part of the problem, or maybe even rethink your design, where perhaps if you have a bunch of turning vehicles or heavy traffic, like maybe that area might not be the best for permeable. And similarly, it's kind of seems counterintuitive, but we find that a flat installation, or one with a pretty consistent low slope, allows you to have those little ponded areas where the water can just skip over to the next joint, and then you can kind of reduce your maintenance a little bit based on that. So kind of the visual inspection can help inform surface needs, but also perhaps structural issues. And if you don't have any ponding in your surface, any dips down, then you're okay to have a little bit of surface clogging.
Yeah, we put our first application in. My boss at the time asked me to stripe it for parking. Well, I told her I thought it'd be better not to allow people that very parking rather than being dedicated. So it hasn't ever been striped in 6 years. We have plenty of parking spaces available with it. So I've not seen that with any of the applications that we have. So just something I decided not to do right from the get-go. I think there's been some benefit to it probably.
Yeah, that's really interesting. And I'll echo that too. We've noticed, again, we've done some permeable pavement research, looking specifically in the winter. What happens to the surfaces are more or less snow and ice. And one of the things we observed on some of the pavements, whether it was parking lots or roadways, was that rutting that Allison mentioned, and especially in the parking lots, like Craig was alluding to. If it's designated that the wheels are always going in the same spots, that can be an area where you're going to get more wear, you're going to get more sediment because it's being carried in with the tires and the vehicles and the wheel wells, and you're likely going to get more clogging. And that's where we saw more ponding, less infiltration, and even in cases more snow and ice, just because it can't infiltrate. So that's great. I think those are really good observations. Those are things to look for when you're out doing inspections for permeable pavements. They are some good indicators. But if you want to get a good measurement, it's good to try to do some of these infiltration measurements as well. So with that, thinking about inspections, that often leads to maintenance, right? You're doing your inspections to figure out, do you need to do maintenance? So a question that came in was, do you believe that regular annual maintenance, if you're doing a regular annual inspection, and they're also doing your regular annual maintenance of sweeping, do you think that increases the chances that you prevent costly rehabilitation or restoration? Is there any even anecdotal data towards that? Or are you just always going to have some level of routine maintenance and some level of non-routine restoration, rehabilitation maintenance with these pavements?
Well, I think there's always going to be something with these applications, but I think they're going to be less than what we do with, say, a biofiltration basin, or even just a rain garden type application. We are looking at reconstructing our downtown, and I feel that the permeable pavements is going to be our best approach. I've been asked not to put rain gardens in the downtown. For me, I like them. Give some green in our community. They provide a different approach for stormwater management, but that's on me to educate. And but I I still think you're gonna have, whether you have annual sweeping, you're still always gonna have maintenance with products. And that's something as we deal with in the public service and public works spectrum, that we are gonna have those things because we're building them and we're putting them in place. So it's just something that goes with the benefit. So that's how I kind of see it.
Yeah, I would agree. We're seeing, and I don't know if we have enough years of seeing good maintenance done on these to know what will be needed in the future, but we have a lot of years of people not doing proper maintenance or, being maintained at all, to show that we do see a lot of expensive refurbishings needed. I would like to talk to Allison about that because we have a couple sites where, I think we need to start over. So definitely not doing maintenance is a downfall. And one thing we're trying to be better about, and Ryan mentioned this in his talk, is making sure that you do proper construction observation, making sure these go in properly so that you avoid any bad maintenance issues in the future.
Yeah, my advice on maintenance of all stormwater control measures is along the same lines of Craig's. You can pay me now or you can pay me later, right? And if you pay me later, it's probably gonna be a lot more than if you pay me now, right? So yes, there's going to be a point at which you hit the point of needing rehabilitation, no doubt. But I think that if you do your routine maintenance, you can increase that cycle between those major rehabilitations. And I think that stands to reason from an internal combustion engine, right? Same idea.
Yeah, I just add, like I said, it's really important to, ahead of time, look at your drainage area and see what you can plan for and anticipate. Perhaps, if you can find some sort of pre-treatment, or as, Ryan mentioned, just assume the first however many feet of your pavement are going to be clogged. You can plan for that. But sometimes you just have to collect anecdotal information over time and let that inform. So, we have a residential installation. It's not permeable pavement, but we learned this past winter that it got sanded way more than our city had ever, had any records of or that we had planned for. So now we know moving forward, perhaps that there are certain times a year where we should get in there and do sand removal where we wouldn't have before. And I just would be remiss if I didn't say, I'm a big fan of permeable pavement, but I'm also a huge fan of vegetated green infrastructure. So we definitely support that because we are lacking vegetation and tree canopy cover. So that's why we typically promote vegetated over permeable, but I just couldn't get away without saying that.
I really appreciate that, Allison. And for our audience today, we've actually had a number of seminars on street sweeping, on trees, on vegetated systems, bioretention. So if you're interested in any of those topics and hearing our national speakers on those, check the links. I'll post some in the chat. You can see all our recordings on our YouTube channel. Tune in for those and watch for future ones on that. But I want to hit on a couple things. Actually, something that Craig said ties into one of the questions I wanted to ask next, and some of the others as well. And the big question is, what do we think are our most important needs related to this topic? So we've already kind of said there's only a few installations here and there, and a few is relative. If we talk about Minnesota being the land of 10,000 lakes, Minnesota is also the land of over 30,000 stormwater ponds. But when we did a survey of permeable pavements, we're talking less than 100, right? So the big question is, what are the important needs for where we want to grow the use of permeable pavements? And then how it ties to what Craig mentioned was education, right? How do we communicate effectively about permeable pavements with stakeholders, citizens, and the public? Is that maybe one of the barriers to getting more of these permeable pavements in place? Or is it more unfamiliarity with design or construction? Not knowing some of the lessons learned that Ryan shared today, maybe those were some of the barriers that we just didn't know what is best for run-on ratios. So I'd like our opinions here collectively from the panel. What's kind of holding us back? What are our needs? And whether that goes to research or whether that goes to public engagement and education, let me know your thoughts.
Well, I think since I feel like we have the biggest barrier here, I can speak to that. I think I might have the opposite for stakeholders. I think our stakeholders, our community members, are calling for this type of treatment more so than our internal are able to put it in. So I think we're kind of set up really well there. We are responding to needs from the community. But I think we would benefit greatly from, first and foremost, like a really well-informed and well-practiced maintenance contractor atmosphere. So having a bunch of folks that know what they're doing, that can be competitive in their bidding, that have options for equipment to use, that have tried and true methods that we can just, trust that it's going to work the first time, it's going to cost this much and take this long. They have backup plans and all that. So that's really important. And then stepping back, of course, with our science-based aggregate permeable pavement, just making sure we really have the science honed in for the specifications, the right times to check during construction, to make sure our installations are going in properly. Because as much as we're talking about maintenance for stormwater reasons, structural and surface is just as important, especially in Minnesota here where we have such harsh winters. So those are probably our biggest barriers, or making sure those are all done well.
Yeah, I'll echo that too. I think for us, we use a lot of, like annually until this last year, we had open house events for our public works, public services operations, and we use every avenue during that to hit on mostly stormwater stuff. And it's relative even to the winter maintenance aspects of it. But trying to, with our downtown reconstruction, we started that process early, and our council decided to push the project back because we had impacts of COVID last year, of course, on our downtown customers and clientele wanted a reprieve for another year. So we decided to do that. This is actually going to give us a little more time to further engage the businesses and the public on the things that we're going to look at for permeable pavements downtown, which is huge. So I agree. I think take advantage of opportunities to reach out to people on different aspects. For us, I'm really interested in seeing how our new turf parking lot's going to go, because we haven't applied that practice yet. But from a paved drain standpoint, I think we've been very successful in our plans and establishments of those. So I guess that's kind of where I'm at right now. But and educating staff is huge as well. Allison's talking about may not have the staff engagement. I know we struggled with that just a little bit to start with. We moved a lot of that activity over to our utilities department because they deal more with the water aspects, and that's helped quite a bit. So street guys sweep it, they get involved a little bit, but we're fortunate we're small enough we can shuffle some of those responsibilities around. So
I think I'll add a couple of things to this. So my first thought would be the structural design, I think, is actually, and this is coming from a water resources engineer. I'm talking a little bit outside of my area of expertise, obviously. But the structural engineers, when you start talking about potentially storing water underneath the road or having the subgrade be wet for, let's say, a quarter of the year or more, they start to get a little bit nervous in some cases. And so I think getting some familiarity there and getting some examples in the ground of structural designs that work, that do reduce some of that rutting that you mentioned, Andy, and I've seen in a number of places as well. And then the other piece on the research side, I think one of the missing links in this particular type of stormwater control measure is really the ability to control dissolved pollutants. And we all struggle, particularly here in Ohio, we struggle a lot with dissolved phosphorus and Western Lake Erie Basin and algal blooms. I'm sure you guys have some of those same issues in some of your inland lakes. And so, this practice does not do a lot for dissolved phosphorus, nitrate, dissolved metals, things like that. And so coming up with sort of things that we can add on, little tack-ons to a typical permeable pavement design that would capture those pollutants, I think is a next step that we need to take.
I don't know if I have much to add to this. Everybody covered almost everything, but one thing that I've noticed is that we were seeing these, a lot of our cities have living streets policies, so trying to make their streets more livable, more green friendly, more accessible to people. And one thing, when people see a change in pavement type, so when you go to normal asphalt to a porous paver or a paved drain setup that just triggers a need to slow down. So some cities have used it in that way. So getting another benefit, also using them in crosswalks or in front of buildings that may be a little slipperier and you may have tendency for people to fall. So, promoting that aspect. And then just, I think Craig touched on education, but letting not only city and public staff know how these can be beneficial to them and the maintenance required, but also letting the public know, the benefits to these, why they're being installed, why it looks different, maybe why, if they're paying attention to cost, maybe why it's a higher cost up front or whatnot. And then I do want to give a shout out to the City of Shoreview. They've done a lot of paved drain and other porous asphalt systems, concrete and whatnot. And, so we direct a lot of people to them where they can give the truth and, pros and cons about what they're seeing as far as maintenance and installation. So I think having a advocate like that to send people to get the upfront information is beneficial too.
That actually brings up some of the other questions I wanted to ask. We kind of started to delve a little bit into design and siting, and I'm always an advocate that there's three legs to any of our stormwater projects. You got to have good design, good planning and design, and Allison kind of harped on the trajectory here, right? You got to have good construction, and then you got to have good maintenance, right? If you're missing any one of those, it's likely not going to last for very long. So we've talked a fair amount about maintenance and operations, even inspections. There's a couple questions related to design that I think are good to talk about to kind of overcome those hurdles. The first question actually came in during Ryan's talk related to the milling depth. And the question, what's the typical depth of porous asphalt compared to how much you milled in your testing? And I'm actually curious for the local panelists too, what are the common depths for your permeable pavements in your systems, if you're aware of those numbers? And that gets to how many times could we possibly mill this pavement if we can't overlay it because of the binder? How could we make that thickness bigger so that it gives us opportunity to mill multiple times over the life before having to replace the pavement? So let's tackle that question first, and then there's another design question I want to follow up with that.
So my experience has been porous asphalts. The ones that we studied in Sweden were 4 inches, roughly 4 inches thick. And that's been 4 to 6, somewhere in there is what I've typically seen spec'd on plans.
We haven't really dealt with porous asphalt or concrete, so I really can't answer much to that question, I guess.
I'm in the same boat. No, we had some concrete, but that's gone, so no more aggregate for us.
Yeah, and I think we see exactly what Ryan said for those standard depths.
Yeah, did you want to add, Ryan? Go ahead, please.
Yeah, I mean, obviously, milling is going to work a lot better on an uncurbed road where you don't have that gutter elevation to hit. So just keep that in mind. There are situations I showed in the first slide of my presentation, the highway site with the porous friction course overlay. Those are used quite a bit across the country, and we see pretty darn good water quality improvements from those systems, similar to what we see for full depth permeable pavements. So those are quite a nice highway specific BMP if you're interested in highways particularly. They do a really good job of sediment control and other sediment bound pollutants.
So then the other kind of design question, and maybe it's less design and more of a siting question, where do we put these things effectively? And it gets to the soils, right? The subsoil. So typically we'll have a permeable pavement surface, we'll have some subbase. That can be, upwards of 3 feet of rock, open rock to store water, right? But then the subsoils can become important. And I'll just mention the Minnesota Department of Transportation has a research facility called MinRoad. and they had a number of their test sections of permeable pavements, and some of those test sections were over sand, and some of those test sections were over silt and clay type subsoils. So very different subsoils. Neither or none of those designs had under drains that I was aware of. And so the question gets to that aspect, those subsoils. In many places we've seen the permeable pavements go in, it's over sandy soils. There's a few instances where it's over C and D type soils or silts and clays. But that I'm aware of, at least, I don't know of very many that have under drains. So what do you know about? Are any of your systems under drained? Are you citing your system specifically to be in areas where you have good subsoils? How are you tackling that issue? And then maybe maybe this is a kind of a niche component, but if there's sensitive groundwater or drinking water wells, things like that, I don't know if you encounter any of that in your areas, that could also play a part in where you plan to put permeable pavements or maybe not put them.
From our aspect, we have under drain under everything, because we have the heavy clay soil, so we probably still get a little exfiltration into the soil, but not like you would in a sand-based element. And it's just really for us, and it's set up about 6 inches off the bottom, so we do try to get some of that exfiltration going on, but typically it's all under drain systems.
And Craig, before you move on, are those under drains? Do you have valves? You obviously don't have valves on them if you have clay soils underneath, right?
Correct. They're not valved. The only thing that I have valved today are filtration benches where I'm using the stormwater for irrigation. I shut those off so I keep the volume there. So those are, pretty much everything we have has an under drain system in it.
Yeah, I don't know that many of ours have under drains, and yeah, so we're typically see them not. I can think of a couple maybe where they have really poor soils, like Craig mentioned, where we have it as a backup. I think they do have a valve on there though, so that we can open and close that as needed. But typically, yeah, we more see that in the filtration basins. But yeah, typically we don't have the under drain, and just watch for make sure that we do proper soil tests so that they're going in somewhere where we hopefully we'll get infiltration.
And we definitely prefer the lower engineer, lower maintenance of not having an under drain. So that's going to be our ideal, is that we allow just for straight infiltration. If the soils are limiting, then obviously, we're kind of more used to a drawdown indicator for typical green infrastructure. So obviously that's not a concern on permeable pavement. But you do have to consider, how long it takes the base to drain. And are you concerned about back-to-back storms? What are you really planning for? Again, kind of going to your level of service and what you're expecting out of your pavement. So with that, we kind of follow the Minnesota Stormwater Manual for guidance along that, and just look at our drawdown within our base. And if that's going to be a problem, then we would recommend an under drain. But yeah, try to limit that just from a maintenance and, engineering perspective.
Yeah, we're not blessed with very many A and B soils here in Ohio. Pretty much just heavy clay throughout the state. So almost all of our facilities have under drains. We do push designers to try to elevate the under drain or use an upturned elbow in the under drain, as Craig mentioned, to create some internal storage in the facility and exfiltrate more water. But that does have impacts on the bearing ratio of the soil. Going back to the structural design, it has impacts on that particularly. So if you're going to do that design, there's some interesting research out there from Davis, Cal Davis, that has done some really nice work on reductions in CBRs as a function of how long water is held in the subbase, that I would highly recommend if you're going to do that.
Yeah, that sounds like great resources. So, and for anybody that maybe is not familiar with the putting valves on under drains, that's exactly the purpose, right? And we've seen this in rain gardens. We've seen it really on anything where water goes into a media or a soil. We can put valves on the under drains really as a backup. You can keep the valves closed initially, see if you're getting good infiltration, even in tight soils, if you have enough storage for the storm you designed it for. But then in cases where you have to maintain it or it's clogged, you can open that valve and drain out as much as you can. So we've covered a lot of topics. We've talked about design, we've talked about maintenance, we talked inspections. And we're getting very close to the end of our time here. What I'd like to do at this point is ask one kind of closing question, and I'd like each of our panelists to answer. And the question is, what are kind of the key takeaways that you would give our audience today from this discussion? And the key takeaways that they can use in their jobs tomorrow or in the future that can help improve our water resources, protect our ecosystem health, and improve the quality of life based on permeable pavement use in our urban landscapes. What are your big takeaways? And I'm going to go in the same order that I introduced everybody. So I'm going to start with Craig for his key takeaways.
Well, I think one of the biggest things is to understand the products you're looking at. I'm a little bit leery with turf not having a lot of background information on it. So I think that's really not knowledge of that and what expectations you're looking for, really. And I think, you know, what Paige said, visit some people that have products out there. That's, you know, use your resources that way. So those are really my big things for permeable pavements.
That's great. Paige, what would be your key takeaways from our discussion today?
Yeah, I think the big thing, making sure you're familiar with what maintenance is required and that you have the proper equipment to do that. And then know, like Craig said, there are watershed districts and your WMOs out there, water management organizations that have potentially grant funds that can help you purchase some equipment or help you with equipment sharing. So I think that's worthwhile to look into ahead of time.
Yeah, go ahead, Allison, please. What are your key takeaways?
So this should be no surprise, of course, is that at every step of the way, consider maintenance and be prepared for maintenance. That being said and hounded on, I think, you know, we have a huge job in front of us. So at every moment that we can incorporate stormwater management and water quality, we should be going for it and not get too held back by some of these hesitations. We're learning as we go. But we've also seen a ton of success. Obviously, all Brian's research has been relatively positive, and lessons learned very much can be incorporated. So I would just encourage everyone to keep kind of charging ahead. I also think that, you know, I mentioned it'd be great if we had a more robust maintenance workforce. Well, that's also on us to create the opportunity. So, you know, as much as we can keep pushing that and asking for more, I think is really important.
That's great. Thanks, Allison. Ryan, the last word.
Oh boy. All right. I've got a whole minute. Wow. So I would say planning and scale are the two words that I'd like you guys to take away. So planning, definitely, to follow on what Allison said throughout the process, thinking about how do I plan for a pre-construction meeting to get across to this new contractor who's never done this before? What are the key steps and key takeaways that he or she needs to know, right? At the city level, planning in advance for maintenance and thinking about what's the staffing look like? Is it public employees? Is it private? Are we contracting this out? What are the materials that we might need in order to do that maintenance? Be it a truck, an add-on, like Craig talked about, vacuum, whatever it might be, right? What are the things that we don't currently have that we need to obtain? And then scale would be the other one. I think that right now in Central Ohio, we have, I think, something like 12 million square feet of permeable pavement in the Columbus region. So it's getting big enough where the contracted agencies that do sweeping and the like understand what it is. And you can call them up and say, hey, I got this porous pavement at my hot dog stand. Can you come out and sweep it 4 times a year? And they just get you on the schedule. There's no questions. There's nothing that has to be conveyed. And so I think as you scale up, those maintenance tasks and things that can be seen as challenges just end up being routine at the end of the day. So that's the other piece that I would say is it's important to get to a critical mass.
Yeah, that's great. I think that really sums up this discussion that we've had today. So I want to thank you, the audience, for joining us today. Thank you very much for your questions, for your engagement. Obviously, we could not get to all the questions today, but I will share all the questions with our panels so that they can provide answers, and we will share those answers when we send out the link to the recording sometime next week or the week after. So again, I really thank you, the audience. I want to thank Ryan for the keynote. I want to thank our local panel members, Paige, Craig, and Allison, for being on the panel discussion, providing these insights. And I want to thank you for joining us. And that will conclude today's Minnesota Stormwater Seminar Series. Tune in for future seminar series events and sign up for the updates newsletter if you'd like to hear about those events as they come out. Thank you.